Hi all, I'm going to do this revision session for you on Monday. I'm pre-recording it, so don't send any messages. If you want to ask me about anything like this, then please get in touch with me either via email or pop in and see me at any stage. That's not a problem. I'm going to go through the kind of questions you're likely to get each year, standard questions, and talk you through any kind of ideas that I've got on them from an exam marker's perspective. Each year you're going to get a set standard of questions. They might be in a different layout, there'll be extras in there, but there'll be a set standard way of doing it. So each year there's always a question, or there has been always a question based on the function of a product. So how does this product work? What does it do? What does this part of a product do? So in the past we've seen an electric drill taken apart. It's asking what the function of the trigger or the switch is, the cooling slots, the motor, etc. So what does it actually do? This a question always on technical drawing. I'll show you how to get full marks on that one because that's ever so easy. The user requirements question, so we're looking there basically as a specification. There'll be something on electrical circuits, something on use of electronics, that kind of thing. So you take your knowledge from your NEA that you're doing. There'll be a health and safety, hazard and precaution. So it's normally a 6-mark question on that, looking at what the hazards are and what precautions you can take to keep safe. Stuff about CAD, advantages, disadvantages, same with CAM. Quite often how to use CNC equipment or how to use a bit of equipment properly. And then there will be one question that's testing your written English. So we're looking at your quality of written communication. So how you write that one and get kind of clarity of marks for writing. Okay. Other than that, nothing's marked on spelling or anything in your other questions. So it's just one essential one there. So you might have a question on label the function. Okay, so for example, say what it physically does. This allows to such and such. Yeah. So if you imagine we've got a cordless drill, what is the trigger for that you squeeze to switch it on? Well, you're going to press the trigger, which allows the motor to rotate, which turns the drill bit. Okay. What is the function of a light switch? Well, it gives the user control of switching the light on and off. Okay, so you're going to say something and then you're going to kind of justify that thought. Okay, so it's the connecting words that we've got, so which allows, etc. The tire, so if we're looking at a little remote control car one year, so what was the function of a tire? Okay, it sounds an obvious one, but it's there to grip the surface, allowing the car to move forward along the surface. So there's 2 marks for that question. Okay, so what does the tire do? It provides traction, giving grip to the car, allowing it to move forward. We're doing a little bit more than just kind of one words or a couple of words. We're trying to explain everything as much as we can. Okay. Keyboard, what's the function of a keyboard? To input data into the machine by lettered keys, allowing the user to control the device. Okay, so we justify it. We're describing what it does and then justifying what is the benefit of that, what's the purpose of that. It then comes on to technical drawing. So if you look at the pictures here, I'm not sure whether you're going to be able to see this, but I'm going to try and highlight it, or I've got a laser pointer. That sounds even better. Yes. So you've got a size in here over the middle. Okay, and it's always a 4-mark question, and it's looking for basically putting 2 sizes on. So if you look over here, you've got what's called a leader line, which is this bit that comes from the edge of the drawing. So there's a large extension coming from the drawing, hits the arrowhead, and it carries on for a small little way afterwards. There's always a tiny little gap, if you look here as well, between those leader lines and the drawing. So you've got a small gap, large extension, small extension. Okay, and that shows the size between there and there is 13 millimeters, 13 centimeters, whatever we're working in. It's normally millimeters. The number is always above the line and in the middle. So if you look on this one, it's above the line, looking from the right-hand side and in the middle of the line. Okay, it's always above, so there's a little gap above the line there, and the same down here. That's important. Okay, so it's always read from the bottom of the page like this one, the 13, or from the right hand side of the page like the 30. Okay, the final one to notice as well, you've got arrowheads that are long and thin, coloured in. Okay, it should be about 3 times the length going left to right here where my pointer is, as it is high. Okay, so it's long and thin, and they're solid black, coloured in. Okay, so remember the little rhyme, long and thin, coloured in. So we've got a leader line, you've got a line with your dimension on it, your dimension centrally in the middle, you've got arrowheads long and thin coloured in. And if you can put two sizes on, generally you're going to get the mark there. Normally they'll add another mark for showing the diameter, which is a circle with a line through it, like that one, and down here as well. Okay, so it's showing that, and basically that will give you 4 marks. So long and thin coloured in, number in the centre above the line, okay, just off it. Arrowheads long and thin coloured in, okay, remember that one. And that will give you your marks on the technical drawing. Okay, really straightforward. User requirements then. So they're going to ask for 3 user requirements, and think about our NEA where we've done our specification. We could be talking about Access FM, so we're talking about the aesthetics, the cost, the customer, the environment, where's it going to go, what's it do for the environment, the size, the safety, the function, the materials. So the 3 examples we've got here. So the size, what size do you need a part of the design to be? Okay, so you've got to say what you want it to be. It's a specification. We're listing the requirements. It must be this. It must do this. The material, what material will be the most suitable to make it from? So it must be made from mild steel or aluminium because such and such. The cost, how much is the client willing to pay? Okay, what would be a sensible kind of cost for that? Remember, it sounds horrendous, but the exam board don't have a sense of humour. Okay, so don't try and be funny in any of these things. Don't try and do anything that makes you laugh and kind of you think, oh, what a comedian I am. Yeah, if you're putting yourself in my kind of headspace, I'm marking this. I've got 400 of these questions to mark, and I want to do that as fast as I can, purely because I'm getting paid for it and I want to get on to the next one. Okay, so I'm not really interested in your whimsical jokes that you're going to put there. Okay, it sounds hard, but just understand the person marking it is trying to kind of get on with life as well. Okay, so I'm sat here, I've got 3 kids, I've got to kind of show them some attention as well. I need to get through that marking as quick as I can, as accurately as I can. I'm not really interested in having a laugh. Okay. Electronics then, I've put a slide in about electronics to show you things, and I'll print out additional stuff for electronics. So the kind of handout where I've got this slide from, I'll show it you, and you can have that copied. So they ask you to identify the symbol and say what it does. Okay, sometimes they give you a picture, sometimes it'll ask you what the symbol is. So you need to be able to draw a select few. It's normally about 4 or 5 things you'll have to draw. Okay, maximum. Remember to explain it clearly as the functions list in your revision booklet, which I'll give you out. For example, a battery. What does a battery do? Well, it provides a power source to the circuit. Yeah, keep it nice and simple. The battery provides a power source. The switch switches the electricity flow on or off. Yeah, it's either turning the circuit on or turning the circuit off. It just needs that little elaboration, and it's nothing that you don't know. Even if you're thinking, I know nothing about electronics, you do. It's really straightforward, and you just got to kind of tell us what it is. We'll come on to it. We'll do more about this as we revise as well, so don't worry. And here's the picture. So there's a bit about switches we've got up at the top. Mechanical switches, 4 main types of mechanical switches. We've got a push button, push to make switch. You've got a latching switch, which is this one. I can't really read that one. Some kind of timing switch. We don't need to know that one. So the top 2 there. You've got a switch on the right hand side, a cell or a battery. Okay, so a cell is just half of a battery in the diagram form. You've got a lamp, never seen you asked to draw a lamp before, or a voltmeter or an ammeter, a resistor, a variable resistor would be good, and a motor. Okay, so I'd be looking at a switch, a cell and battery, I'd be looking at a resistor, I'd look at that, and possibly even a diode, which we can come on to later. Down here it tells us what they do. So what does a resistor do? Well, it stops the flow of electricity or reduces the flow of electricity to keep it safe for another circuit, another component. It stops it blowing an LED, for example. That's another one we need to know the diagram for, an LED. Okay, so it limits the amount of current passing through an LED. It's used with a capacitor and a timing circuit. Some publications ignore that bit. Some publications we don't need that bit. So it's just knowing a few symbols. We'll add those on as we go along. We'll draw those kind of things to kind of build up our knowledge more. And in lessons, we'll look at that and we'll look at drawing those things. So don't worry too much about that. One of the favourites for an exam question here, really straightforward to do. So it showed us a machine. In the past, we've had the lathe, we've had the pillar drill. You could look at the milling machine. It's going to be limited because, you know, all schools have got to have them or have access to them or kind of show experience in them. So you can't have anything fancy. It tends to be like, show us what a hazard is. A hazard is something that's going to cause a danger. Okay, so long hair, for example, long hair on its own is not a danger. Yeah, I'm not going to get attacked by my wife's long hair. Yeah, her hair might get caught in a lathe. That is very, very dangerous. Okay, why is it dangerous? Well, it could lead to kind of scalping where the hair's pulled out of her head. It could bring her head close into the machine, obviously causing entanglement and possibly a lot of facial injury, etc. What precaution could we have for long hair? Well, we could tie it back. We could put in a hat, yeah, a safety hat, for example, to stop that hair falling down. So think about seeing people in factories where they've got hats on, safety helmets, or even just kind of hair nets to stop their hair falling towards the machinery. Debris flying off the machine, so you get swarf, you get cuttings, etc., coming off that lathe. Well, we need to wear goggles to protect our eyes from being damaged. We need to make sure the guard is in place. Okay, lots of easy ones there. The workpiece could be loose and flying off. Okay, so if you're on the lathe, if you're not tightening it up fully, it could come loose. It could fly out of the work. On the drill, you've not put it, you've not clamped it down in the vise, for example. So you've got to check that the work is tightened before starting periodically throughout the machining. So obviously, once it's switched off, you check that for security and safety. Okay, so things like that. Electrocution could be a good one. Okay, so how would we prevent electrocution? We'd have weekly or monthly checks on the machinery to make sure that everything is safe. There's no loose wires, no frayed wires, that kind of thing. You could be talking about other people distracting the user on a machine. Or the precaution is ensuring only one person stands in the safety box, and that's a meter around each machine, basically a safety box. And we've got lines painted on the floor in school. Okay, so only one person should be stood in that machine box, if you like. If you get asked about advantages and disadvantages, you've got to make sure that you write about both. Okay, it sounds obvious, but we're looking for, as a marker, normally 4 advantages, 2 disadvantages, that kind of thing. Okay, so we're looking for a mixture of the two. And you know, disadvantage of CAD is very difficult. You know, we brought this kind of system in to make things better. So an advantage is CAD, then a greater degree of accuracy. It will enable it to be kind of machined or cut down to a finer degree of accuracy than you could do by hand. Easy to modify and change any mistakes, so you can zoom in to give you that accuracy, and then you can change things live on screen. If you've drawn it by hand, then you're going to struggle. Okay, you can't alter it so easy. You've got to rub it out, probably even start again. Okay, a lot easier. It's a lot quicker to work that way once you've been trained as well. CAD files can be stored and transferred electronically to the CAM, computer-aided manufacturer of machinery. So when we're working on the laser cutter on your NEA, think about that. We send it electronically. It's saved. It doesn't have to be kind of printed out in the olden days. Okay, so when I was training to be a teacher, my brothers were architects, or still are at the top now. But even when they were training, they had great big chests of drawings in their offices, full of drawings about the size of a table or 2 tables in our classroom. Great big chests, lots of them, to store drawings for several years. Okay, so they drew on paper before we had CAD to be done electronically. Okay, disadvantage of CAD, then it takes skilled people to use the software. So you've seen with your knowledge on Fusion, Onshape, 2D design, it takes a lot of skill, a lot of practice, a lot of years of practice. Some of you have kind of clicked with it really quickly, but still, you know, what you're doing is limited. Okay, so it does take a lot of skill and a lot of time to kind of learn that skill. The initial setup costs are high. We've got machinery, software that's free. But if you were to do it in industry, the computer package we use is about £3,000 a year. The drawing package, 2D design for the laser cutters, is about £600 a year. Okay, so it's high initial setup costs. It's a standard one to use with machinery, with anything to do with design. The setup costs of it are expensive. And software maintenance, repair costs. So when you're in industry, you need someone, you need IT people there to maintain the software that you're using, maintain the machinery that you're using, the computers. Okay, we're lucky we've got 3 or 4 IT people in the background doing that for us. You don't see it very often, but when there's damage, when there's problems with software, they're there to help us. Okay, not subject experts in the software itself. In industry, where you would have that kind of person on hand to help you. Okay, so that's CAD. If we look at CAM then, again, greater degree of accuracy, so the machine would make it very accurately for you, and that's repeatable, so it can be done time after time again. So if you're making the same component, it can make it a lot more accurately than you would by hand. Not to say you can't do it by hand, but it would do it repeatably a lot easier for you. Complex designs are more feasible than by hand. So if you think about 3D printing, you're doing stuff there that you really can't make by hand, or would be very, very difficult to make by hand. Disadvantage, it takes skilled people to use the machinery. It's training costs to kind of get that machinery set up and ready. Maintaining the 3D printers, for example, the printers themselves are about £150, so it's not expensive, but then we need lots of people to be trained on how to set it up. Okay, how to maintain it, how to look after it. Okay, there are high initial setup costs. Thinking about injection molding, you could be talking about thousands, tens of thousands, hundreds of thousands to buy that machine. That then once you've got that machine, it's very easy to run lots and lots of different projects with it, but the initial setup costs are expensive. Equipment needs maintenance and repair. Okay, so you've got to have someone trained to do that kind of thing. Great job as well if you're interested in that kind of thing. All right, so have a look at that one. How to use a piece of CAD CAM machinery. So it's normally around 6 marks on average. Okay, so if we think about bullet points, 6 marks, let's bullet it through and let's say, right, let's aim for 6 or 7 pieces or statements, and then you should have that covered. So it's normally designed on a computer. So there's your CAD. Okay, checks carried out on the design. So we check to make sure that we've got things right. We've got no kind of stray lines, because if we're going to cut it, for example, on a laser cutter, we need to make sure it's not going to cut any material that we need. It then produces what's called G code. G code is the kind of machining code to tell that printer where to move to. It's the kind of graph coordinates, if you like. That's then sent to the CNC machine, such as a plotter, the laser cutter, the plasma cutter, 3D printer, whatever you want to call it. We then adjust the settings. We tell it what material we're using, how fast to cut, how much power. We load the material into the device. The object's cut or printed. An 8th one, it's finished off, taken out, and cleaned up. Okay, so we've got easily six kind of statements there. Okay. Ooh. Bear with me, that's Mr. Bulmer calling me. I'll call him back in a moment. So next one then, written communication questions. So normally around 6 marks. It tends to give us 3 marks for the quality of what you're writing, and then 3 marks for the quality of how you're writing it. So if I go straight down to this bottom bit down here, which is the only one I really want to look at. Okay, so when I'm marking, I kind of go from the top and right, how many marks have I got to take off? I'm not trying to give you marks. I'm trying to look at how many I can take away, if you like. Okay, so excellent understanding of the issues above. Candidate comments in detail on 3 or more of the issues. So there'd be a list of issues. It's talking about, I don't know, let's talk about the environmental issue of disposing batteries in landfill. Okay, so you could be talking there about the leakage of the material from the battery goes into the water course, which in turn feeds the fish, the animals that would be then poisoned or infected, if you like, with battery acid. Okay, there's better ways of doing this. You could be kind of putting it in recycling centres, the local supermarkets, etc. So if you can talk about 3 or 4 issues there to do with disposal of batteries or whatever the issue is. Response shows excellent use of engineering terminology. So I'm using the right kind of words. Okay, so I'm not trying to use stuff, things, and words like that. I'm trying to talk about reasonable wordage that's coming on. Okay. Candidate displays high levels of grammar, punctuation, and spelling to give a technically accurate response, like this sentence here, or this paragraph, should I say. It's split up, it's got commas in, it's got full stops. So we're not making the marker read everything, there's no full stops. Okay, so just think about writing it and then having a breath. How you'd read it, you need a breath to stop it. So candidate displays high levels of grammar, comma, punctuation, and spelling to give a technically accurate response, full stop. Okay, and then I'll move on to something else. If structured using bullet points, then detailed sentences must be employed. So you can do it in bullet points, but you've got to write in sentences, full sentences. Okay, it doesn't have to be a paragraph of beautifully written English. It can be a series of statements made with justifications, again using the right kind of full stops, commas, capital letters, looking for well-written response. Okay, but it's not massive. Okay. The most I can say there is make sure you do something, otherwise you get no marks. Okay, so nothing worthy of credit. Basically said you've either written something that doesn't make sense, there's nothing in there, or you've not written anything. Now try to write something. Okay, you can at least guarantee you've got a 50-50 chance of getting some marks there. Okay, if you don't write anything, you've got a 100% chance of getting 0. Okay. So if we have a look at this then, discuss the following aspects of the location of wind turbines, giving both advantages and disadvantages. We're looking there for maintenance, impact on the environment. Okay, so if we go for maintenance for a start, we've got 8 marks. So we're looking at 4 for each. Okay, 4 marks for each. We're looking at 2 disadvantages, 2 advantages maybe. Okay, so we're breaking it down again. I probably just try and write as much as I can though. So I'm talking about an advantage of an onshore one, which is this one on the left. I can access it very easily. It doesn't matter what time of day, what the weather's like. Okay, I can go there. I could switch the turbine off or break it so it stops it from moving. Obviously, I don't want to go up there and maintain it while it's moving. That would be quite dangerous. So we're going to be able to access it by driving onto the farmers' fields. Yeah, very easy to access. The disadvantage of that is the farmer might decide to charge us. Okay, so you can imagine that he's got lots of turbines there. He's going to say to the company, well, I want you to pay £50,000 to come and service my turbine. Well, the energy company's got to pay that, because short of hiring a helicopter, there's no other way to access that. And a friend of mine that used to come into school to help us, works for E.ON on wind turbines, or used to, talked about they had one on-running argument with a local farmer who was charging them £300,000 to access this one turbine to maintain it. So they actually decided to hire a helicopter because it was cheaper, and dropped an engineer from a helicopter onto the turbine to service it. That's rather extreme, as you can imagine. So the advantage of it is you can access it. Whereas the ones at sea on the right hand side over here, you're going to need a calm, still day so you can access it. You're going to need a boat, so you've got to get out there. Okay, so we need it to be calm and still so we can get that boat out there safely to dock onto it to get the person onto the turbine. So you've got to ensure the right kind of weather conditions, and maybe during the winter the weather conditions aren't going to be calm very, very often. Okay, so we need to be aware of that kind of thing. Impact on the environment. Well, visually you can't see them normally out at sea. They're not impacting anything out there. You don't tend to get migratory birds, so birds flying kind of over the sea so much, but over land you're going to have birds flying in their usual pattern to go on migration. Bats and things like that you have to allow for that fly around, and also you've got the kind of eyesore of it. So the visual impact of wind turbines, a lot of people don't like it. Okay, so that they argue that they're not attractive to look at. I quite like them. It doesn't bother me. I'm not sure I'd want one in my garden, but I quite like them. It's obviously a way forward. The area needs to be very flat around wind turbines, so you don't get kind of swirling wind. We get that kind of flat, constant wind, which is why they're particularly good on the sea. Okay, on to the next one. Discuss the following impacts of the location of wind turbines, giving both advantages and disadvantages. So what we've done, and you can see that's how much. As an A4 sheet of paper, you're expected to write a long, detailed answer. You could split it up into kind of 4 chunks. Okay, so we're looking at maintenance impact on the environment for both of them. You could talk about positives for each and a negative for each, and then you're breaking it down. So we're getting that 8 marks covered. So how would it be done? Positives, negatives, 2 things to talk about. Okay, so it's quite easy to get there. It doesn't matter whether we fill all that page. Okay, what they give us so much room for is stereotypically girls with bigger handwriting, bubbly handwriting, people that tend to go wrong, and to allow you to express yourself and give your thoughts. If you wrote half a page, you could conceivably still get that 8 marks quite easily, as long as you're giving 8 statements, 8 kind of excuse me, 8 justified points. Okay, so don't worry about the writing, but that's how much kind of space they would give you for that. It's a whole sheet of A4 paper. Let's have a look then. So land-based ones, normally easy to gain access for maintenance. Some locations are in very remote places, less changeable weather conditions, so it's going to stay kind of stable. Easy to transport workers and spare parts to the location. That's kind of what we said. Can have significant effect on visual impact, so the eyesore of it. Turbines are noisy and annoy local residents. Take up valuable agricultural land. I kind of question that, because they don't actually take up much land at all. But you could talk about that you know, we've got that ability to have animals kind of grazing around it. You wouldn't probably go ploughing your fields with those in there, but you could graze animals. Offshore then, time and money to get workers to the site, so it's going to take time to get out there to them, because they're normally about a mile off land at least. Dangerous sea conditions. Okay, so we've got to consider that. Tend to be much bigger turbines, so hazards with working at greater heights. So you've got kind of 80-meter turbines and massive things. Have to consider tidal conditions. So we've got to think about how much the tide goes in and out. Less visual impact because they're not on land, they're out at sea. No noise issues for people. Greater corrosion issues with salt water. The exam board loves using salt water as an issue, purely because it's very, very corrosive. The salt wears away things. So you need to consider what kind of finish goes onto something when it's in saltwater conditions. More difficult to transport tools and equipment offshore. So you've got to think about, right, I've got this boat. If I've gone out on a boat, I've got to take everything with me. Sorry. If you get there and you actually need something different, you might find it's going to be a very expensive trip to come back to shore and then go back out again to take that specialist bit of equipment with you. You can see how this is again marks. So we've got nothing relevant of response, all the way up to comprehensive knowledge of the aspects. It's evaluated both locations, good range of aspects considered, not just flipped it. So you can't just say onshore wind turbines are noisy, offshore ones are quiet. Yeah, that's a flipped comment. We don't do that. We don't just say the alternate thing for each one. Maintenance and environmental factors considered. Okay, so you can see how we should be going up to 8 marks just for putting kind of statements here. You don't need all of those statements that it's showing here. It's just having a good understanding of them. Oh, I was going to say, I thought I did some more. At the start of the test, there's normally 10 marks on a multiple choice, and it asks you to colour this lozenge being these little kind of shapes here. So you colour that little dot in, because that's marked by a computer, not by a human. Okay, so they literally scan your paper through it and it marks what you've done. So if you go wrong, you put a big cross through it and then you colour it in again, and it will tell you what to do if you go wrong twice, other than kind of give up with life, but let's not go there. What's the name of the force that opposes the forward motion of an aircraft through the air? So what's holding an aircraft back, or holding anything back? We're looking for drag there, so it's holding it back. Lift is the thing that goes up. Pitch is when it twists and turns. Thrust is what's pushing it forward. So drag holds something back. If you think about a car driving, it's going to be held back by drag, a force that opposes the forward motion. There we go. Cars can be powered by fossil fuels such as petrol and diesel, or by batteries. Analyse and evaluate the use of both technologies to power cars, taking into consideration the following aspects: environmental impact, ease of use for the car driver. So again, I'd split my essay up, because it's essentially asking you to write an essay or bullet pointed list well written, into 2 bits, and make sure I'm keep talking about environmental impact and the ease of use for the car driver. So let's have a look then. Fossil fuels are a finite resource. So we know that fossil fuels are running out. So that's one analysis, 1 point, which is environmentally damaging in the long term, will lead to high prices for the user. 2 marks. Fossil fuels create harmful substances when burnt, which can enter a person's body, resulting in health problems. So we're breathing those fumes in. There might be environmental effects when being mined or sourced, which can lead to pollution and visually damaging. So we're digging big holes to get at this equipment. Batteries don't generate harmful substances when used in a car, so it's clean energy, which help to avoid health issues and damage to the environment. Batteries still require some initial source of power. So think about that when you plug in your electric car, and you've got to power that still, which comes from your coal-fired power stations at the minute. So there might still be environmental effects through mining, sourcing of power generation. So we get that coal out of the ground. There was a coal source, an open cast mine in Heather. I was born there. They dug that. It started in the early 80s, I believe it was. They said there was 3 years of coal to be dug out. 26 years later, they finished. It left a massive scar on the environment, which is where the country park is now. So they've actually made it very nice, but when it was fully functioning, I drove down there in a Land Rover. It took us about 5 minutes to get from the top to the bottom. Okay, so quite a significant time to get down into the hole, okay, where they were digging this thing from. Electric cars are quieter than petrol engines, which can be a pleasant benefit to pedestrians, but can be dangerous for the road users if they can't hear these cars. So if you've never seen anyone nearly knocked over by an electric cars are actually silent. They're made to make a noise for kind of regulations and safety, so they should be silent. They make that kind of whirring noise, so at least you know that they're coming there. Batteries need to be replaced or disposed of eventually, causing problems regarding recycling and safe disposal of chemicals and materials. Okay, so we've got some kind of detailed stuff about the environmental impact there. Again, you don't need to remember all of those. You could be putting 2 or 3 of those in. Ease of use. Petrol stations are numerous, or far more numerous than recharging points, so less of danger of running out of a power source. I'd love a battery powered car, but we go down to Bude down in Cornwall each summer for a holiday. We go down Easter this year as well. 240 miles, so you'd struggle to get down there on one charge of a Tesla, for example. Can't afford a Tesla, but an electric car. So the station, the charging points down at Gloucester way, Gloucester Services or Bristol, about 2 hours drive from here. The charging points are always all booked out or used. Okay, I've rarely seen an empty one. Whereas petrol stations are plenty. You know, I could drive onto the edge of the motorway and get some petrol. There might be a queue for a minute or 2, but you know, we're queuing up for petrol. We'll move on. A charging for a car might take an hour or more to recharge it. That's not saying it's a massive issue, but it is something to consider. Okay. Where am I? Limited range for battery powered cars, which may mean getting stranded, means making more stops to recharge. So you've got to think about that. Filling a car with petrol is much quicker than charging a battery. Less time wasted when stopping leads to shorter overall journey times. Okay. Batteries can be charged up at home, which will save time and money and be more convenient for a driver. So I could plug my car in overnight and charge it on the driveway, and it's ready then. I've already paid for the electricity, so it's there ready for me. Okay, and that is that. I'll do another one of these later at some stage, but for now, that's everything. Okay, any questions on that, please come and see me. And if you need any support with your revision, please come and see me again, but that will do for now. Okay, take care. Bye.